Welcome back to Educator.com. This is the lesson on earthquakes, volcanoes, and other disasters. All right, a little geologic overview for you. This is actually somewhat of a review from general biology. The time scales in terms of measuring periods of time on our Earth, partially based on geologic evidence. Eons are the longest periods of time. Within eons you have eras, within eras you have periods, within those you have epochs, and then within those you have stages. Here are the three most lengthy periods or increments. So you can see that we have this really long eon, Phanerozoic, and then in there we have eras and periods. So some key principles of the geologic time scale. Rock layers, or strata, are laid down subsequently, with each stratum representing a slice of time. Now that makes sense. When you have movement within the crust and you get, certain violent earthquakes, volcanic eruptions, etc., along with erosion over time, you can see where the sides of mountains have clear, defined layers. You can trace the line and see oh yeah, the rocks are a little different up there, a little different right below that line. And those are the strata marks we're talking about. And then the principle of superposition has to do with that. Meaning layers of soil or rock that are above others are not as old. So the principle is that the further down we go, the older the stratum we're looking at. So related to that information, just want to go over some major events in these periods of geologic time. And like I said, this is somewhat of a review from biology, but this does apply to environmental science as well. When we go prior to the Cambrian period here, you can say that in here you have the pre-Cambrian. And when we go that far back, when we go, further back than about 500 million years ago, we're looking at primitive marine life. We're talking about very simple multicellular organisms and a lot of unicellular organisms. Then when we get into the Cambrian period, right in here, you may have heard of the Cambrian explosion. And that is an explosion of body forms, of life forms. Not many of them were successful, only some of them were, and they have descendants that are alive today. But there's plenty of fossil evidence to show that there was this explosion of species that occurred, a lot of invertebrate species in the ocean, with a lot of different strange body plans and body styles. After that abundant invertebrate explosion, we get to the next one, the Ordovician. You're looking at the first vertebrates. I'm going to write first vert, and of course those were fishes. And around that time you start seeing more of the algae we're used to seeing in terms of those photosynthetic organisms becoming a little bit more complex. When we get into the next one, we're talking about land vertebrates. At that point, not quite the fully developed reptiles we're used to seeing, a couple 100 million years later. We're talking about some fish that had primitive lung capabilities, or we're talking about the ancestors of modern day amphibians. The Devonian, there we could say that is truly the age of fish, the age of fishes, because in terms of the vast numbers and really successful forms of fish coming into being, yeah. And then in here, instead of calling them Mississippian and Pennsylvanian, I'm going to refer to this as the Carboniferous Period. And that's actually a pretty common term. Carboniferous forests, you're going to see that term if you do a search of this, online or in a textbook. So Carboniferous Period having to do with coal swamps. And what that's referring to is the majority of the coal that we mine today underground. We're talking about death of millions and millions and millions and millions of plants during that period of time that led to the formation of coal today. That's led over millions of years to what we extract out of the ground as a fossil fuel. So yeah, thank you Carboniferous forests during mostly this time period. And then Permian, there actually was a major extinction event during the Permian period, but we could say that reptiles really started to get their heyday. Expansion of reptiles to all different areas of the globe, and just after that is what we could call the age of the dinosaur. Dinos, right? Beginning with the Triassic period into the Jurassic and into the Cretaceous, we see dinosaurs. Cretaceous period, they gradually went away. Actually, not quite as gradual. You can look into the extinction of dinosaurs for the various theories regarding that. But dinosaurs really plentiful during this period of time, and also the first birds during this period of time, and the first mammals. Now, based on fossil evidence, mammals came before birds. Birds a little over 100 million years ago, and mammals closer to 200 million years ago. But the mammals that existed during the age of dinosaurs were quite tiny on average. Then you get into the first flowers, probably during the Cretaceous. And then once you get to the Tertiary period, the other name for this, by the way, is the Paleogene period. And then the Quaternary, I've also heard the term Neogene. But Paleogene, you're talking about the first men. Now by men, I mean hominins. So of course it's closer to the end of this Tertiary period. The first hominins, individuals walking on two legs that looked more like us than an ape. We're talking about that far back. And then flowers became, extremely successful. Flowering plants were a lot more successful during that period. And of course, during the Neogene, civilization hasn't been around for that long relative to the age of the Earth and relative to all these periods of time. Just another geologic relationship to this. Right in here is when the Appalachian Mountains started to form, which is interesting to think, wow, that far back. And then when you get up into the Mesozoic, Rocky Mountains formed around that period of time. It's kind of interesting to think about.